This video will provide a brief introduction to fractions. The number above a fraction bar is called the numerator, and the number below the fraction bar is called the denominator. For example, in the fraction 5 over 7, 5 is the numerator since it is above the fraction bar. 7 is the denominator since it is below the fraction bar. To reduce a fraction, we find the largest number that can divide both the numerator and denominator. Then we divide both the numerator and denominator by that number. For example, in order to simplify 15 over 25, we need to find the largest number that can divide both the numerator and denominator. So in the case of 15 and 25, the largest number that can divide 15 and 25 is 5. Then we would divide both the numerator and denominator by that number. We would divide 15 by 5 and we would divide 25 by 5. The result would be 3/5. Notice that 3/5 is equivalent to 15 over 25. Next example, let's simplify 48 over 72. Now we want to find the largest number that can divide both the numerator and denominator. So we could pick a number like 6, but 6 is not the largest number that can divide 48 and 72. We could also pick 12, but again, 12 is not the largest number that can divide 48 and 72. The largest number that can divide 48 and 72 is 24. So the answer would be 2/3. Now let's say by mistake you take 48 over 72 and you mistakenly divide by 6, which is not the largest number that can divide 48 and 72. Here's what would happen. 48 divided by 6 is 8. 72 divided by 6 is 12. We would get 8 over 12. Now, at each step, we have to determine is 8 over 12 in the simplest form. In other words, is there a number that can divide both 8 and 12? So in this case, because I did not pick the largest number that can divide 48 and 72, this fraction 8 over 12 can be reduced further. We can divide both 8 and 12 by 4, which will result in 2/3, and that's the same exact answer we got, except here we did it in one step, here we needed 2 steps. To multiply fractions, we multiply the numerators and multiply the denominators. We can also use a technique called cross-canceling. For example, when we multiply 16 over 9 times 15 over 24, we could multiply 16 times 15 and 9 times 24, then reduce, but that'll give us numbers that are very large. So a better technique would be to take 9 and 15 and reduce them. To reduce, we find the largest number that 9 and 15 can both be divided by. 9 and 15 can both be divided by 3. So 3 goes into 9 3 times, and 3 goes into 15 5 times. Same thing with 16 and 24. We want to find the largest number that can divide 16 and 24. 4 goes into 16 4 times, 4 goes into 24 6 times. Now, look what happened. I made a mistake because 4 and 6 are not in simplest terms, which means there was a bigger number that could divide 16 and 24, which was actually 8. But it's okay if this happens. We just have to repeat this process. 2 goes into 4 twice, and 2 goes into 6 3 times. So we reduced once again by 2. Once everything is in reduced form, we multiply the numerators. 2 times 5 is 10. Multiply the denominators. 3 times 3 is 9. And our answer is 10 over 9. Let's see another example. Let's multiply 10 over 27 by 12 over 25. So once again, we can take anything from the numerator and reduce it with anything from the denominator. So for example, let's take 12 and 27. 3 goes into 12 4 times, and 3 goes into 27 9 times. 4 and 9 are called relatively prime, which means there's no number that can divide both 4 and 9, besides 1. Let's look at 10 and 25. 5 goes into 10 twice, and 5 goes into 25 5 times. 2 times 4 is 8. 9 times 5 is 45. We always have to make sure if this fraction is in lowest terms, 8 over 45 is in lowest terms because there's no number that can divide both 8 and 45, so this is our final answer. Now let's talk about addition and subtraction of fractions. To add any fractions, a over d and b over d, we simply add the numerators and keep the same denominator, as long as we have a common denominator. Later on, we'll talk about what happens when we don't have a common denominator. Same for subtraction. If you subtract a over d minus b over d, we subtract the numerators and keep the same denominator. Here's an example. To add 1 over 5 plus 5 over 8, unlike multiplication, we don't do anything with the denominators. Once we have a common denominator, the denominator doesn't change. We would add the numerators 1 plus 5. This will give us 6 over 8. Every fraction needs to be in simplest terms. 6 over 8 can both be divided by 2, so we will reduce the fraction, and our final answer would be 3/4. Let's look at one more example. Let's subtract 19 over 12 minus 3 over 12. 19 minus 3 is 16. And again, we keep the same denominator. Once you have a common denominator, the denominator does not change. 16 over 12 needs to be reduced. So let's find a number that 16 and 12 can both go into. The largest number that 16 and 12 can both be divided by is 4. So we would divide both 16 and 12 by 4. And our result would be the fraction 4/3.